2.8 vertical angles talks about vertical angles and opposite rays and how to use vertical angles within proofs. To start with the definitions of what each are, we start with opposite rays. Opposite rays are rays that are collinear but extend in opposite directions. So ray BA and ray BC are opposite rays. Vertical angles come from lines or segments that cross, and they refer to the angles that are directly across from each other. So in this case, these right here would be vertical angles, as would those angles. Now, one theorem that some of you have already implied or guessed at is Theorem 18, that vertical angles are congruent. We'll use this theorem in example from page 102, number 4. Given the following diagram with points A, B, C, D, and E, and given that angle A is congruent to ACB, and let's mark that in our diagram. Again, we start with our givens. From there, take a look at the diagram and see if there's anything else we can assume from the diagram. By looking at the diagram, we know that ACB and angles DCE are vertical angles. And again, the reasoning is assumed. Knowing that, we can then say that angles ACB is congruent to angle DCE because of the theorem we just learned, that vertical angles are congruent. From here, we can use either the substitution or transitive property to say that angle A is congruent to angle ACB. Again, the reasoning being substitution or transitive. If angles are congruent to the same angles, then they are congruent.